Good day, everyone. Hi, my name is Bill Dicus, and I am Telit's IoT Platform Product Manager. Welcome to this edition of Telit's Coffee Connection Series. Today, I'll be covering the role of edge computing in 5G. First, let's define the edge. For some, it's a connected factory. For others, it's connected products that are moving about. And for some, it dives deeper into this idea of the whole connected site or the connected machines within the building, all the way down to the individual sensors that are part of this business or operational process. And we need to connect either directly to those products or to the gateways to those devices and sensors. And with that, we need to leverage what that means for 5G at the edge. And for the edge, it means leveraging the key benefits that 5G provides, which includes an increased speed, which means more data faster, lowering the latency so that we can have predictable real-time communications with these operating technology systems. For example, 5G's low latency has significant implications for remote technology, whether it be a process implementing a robot or a chemical process that we need to have that real-time communication that goes between the devices. And then lastly, while the cellular networks are used to billions of cell phones, when we start implementing huge numbers of devices and sensors, we'll see 10 or more times the need for connecting to devices, something that's forcing the new categorization of something called massive IoT. So let me give an example of some of the use cases of 5G. 5G will bring forth the idea that we can replace cabling. In the context of a private network, you can use 5G to replace the cabling in factories, thus enabling for a more flexible system. Today, that's not going to happen. It's going to be sort of a more evolutionary modernization of the factory infrastructure so that they can then take advantage of low latency, high capacity, and increased speeds. But probably a more immediate application will be at the edge will be an overlay within a factory or industrial environment, because most enterprises will not want to take a risk of disrupting proven processes, but they will want to add new applications, new functionality, and monitoring through the sensorization of existing infrastructures and processes. And then the last case is the distributed nature of that 5G will support in the fields, in the environments where there'll be just more and more sensors. For example, a water treatment process requires wastewater to be pumped from many different sites in a controlled manner, and they must manage it in a lot of pumps and valves across multiple sites. And as I said, all of these will be benefited through 5G's increased speed, lower latency, and higher capacity and outcome. And what this all leads to is an outcome of something we're starting to see of continuous intelligence. The idea that with streaming analytics and streaming technologies, we now have the ability to continuously analyze and extract value from the IoT data, the data being generated by each of these sensors and collection points. Where will this be seen? It could be in industrial processes that previously were less than real time. And real time can create a sense of immediacy, but it can be cases, for example, we've seen customers that were only collecting data basically over what we call the sneaker net, somebody going out and collecting the data once a month and walking it back to the data centers for analysis, to data movement that is either minute by minute or instead. And this then also drives the goal of predictive and prescriptive maintenance. Some of these edge processes, which would leverage third-party AI and ML applications that many companies are starting to experiment with and see benefit from, some of that leverages the data transfer and communication that's happening at the edge, and leveraging the processing power that can happen at the edge, but also the characterization that happens through collecting large volumes of data in a centralized cloud-based connection, and then communicating the models down. And then lastly, the optimization at the edge may include operating processes and process improvements. So how does Telit play in that? Today, we have that through our device-wise IoT platform, which includes two systems that are fully integrated end-to-end. One is our cloud system for collecting the data, managing the data, and managing the devices. So it's something that we call a device management system, a connectivity management system, and a data delivery system. And those edge gateways are device-wise enterprise and asset gateways that work at the edge by communicating directly with these robots, computer numerically controlled systems, and then also our ability through our OneEdge and 5G modules to quickly onboard and leverage these systems through our ability to make almost any product wireless at the edge. So that was a quick review of the role of edge computing and how Telit plays in it. If you want to learn more, please feel free to schedule a meeting with us. Thanks for joining me today.